In this video, we're going to talk about how to determine if chemical equations are balanced or not. So we're going to start off by talking about what that means, balanced, a balanced equation, and then we'll talk about the steps, and then I'll show you some examples to help you see how to do this process. So when we're talking about determining if a equation is balanced or not, what we're talking about is the law of conservation of mass. So the law of conservation of mass states that matter is not created or destroyed, it just rearranges. So in a chemical equation, when we're looking at it, we're not going to have more uh, more of one type of element on the left side of the reaction or the reactant side than on the product side, the right side. We're not going to have this difference because matter is not created or destroyed. You're going to see how it just gets rearranged. So a chemical equation is balanced if the atoms of all elements are equal on both sides of the reaction of the equation. So in other words, the number of atoms of each of the elements on the reactant side is going to be exactly the same as the product side. If that is true, then it's balanced. If it's not true, then it's not balanced, which means we've got to figure out how to change the coefficients to make it balanced. So these are the steps to check if a chemical equation is balanced or not. So the first step is you're going to list all the elements in the reactants and then all the elements in the products. So that's going to help us make sure that there aren't any new elements being created. That's not how these chemical equations work. So we're going to make sure all the elements are the same on both sides of that yield sign. So the second step is to work from left to right and using the rules of coefficients and subscripts to count all the atoms for each element in the reactants. So just like we were counting atoms in chemical formulas, we're going to count all the atoms in each of the chemical formulas in this chemical equation. Once you've done that on the reactant side, the third step is to follow those same steps for the product side. And then the fourth step is to check to see that the atoms for all the elements in the reactants match the atoms of the elements in the products. So if the numbers match on the reactant side and the product side, then it's balanced. If they do not, then that means that the equation is unbalanced and the coefficients aren't correct. So I'll show you some examples here that walk you through these steps so that you can see how to determine if a chemical equation is balanced or not. All right, so we're going to start with this example here. It says 3KOH plus H3PO4 yields K3PO4 plus 3H2O. So the first step, it says we're going to list all these elements. So we're going to look on the left side here. So K, O, H, H again, so I'm not going to list it again, P, and then O again. So now we're going to actually fill in the right side here too. So we did the reactants, now we need to do the products. So again, we've got K, P, so I'm going to put it in line here, O, H, and then O again. So now we'll find the atoms of each one of these elements in the reactant. So we'll start here. So we've got no subscript, so that means 1, but we've got a coefficient of 3 there. Then oxygen, the same case. So we're going to multiply that coefficient times that. And then hydrogen is the same case here. So we've got 3 times 1 for each one of those. Now, H3, so we're going to add 3 more H's. 1 phosphorus and 4 for oxygen there. So when we add all these up, this is 3. This is 3 times 1 is 3 plus 4 is 7. Hydrogen is 3 times 1, which is 3 plus 3, that's going to be 6. And phosphorus is 1. Okay, so now we'll look on the product side. So K, there's 3 of those. P, it says 1. O, it says 4 of those. Over here in this compound, we have 3 times 2 for hydrogen, because 2 is the subscript, and then 3 times 1 for oxygen. So we total these up, 3, that's 7, that's 6, and 1 for phosphorus. So if we go through here and check this, we've got 4 elements here. We've got 4 elements here. So those are the same. If we total up the atoms, 3, 7 is 10, 6 is 16, plus 1 is 17. And if we do the same thing on this side, 3 plus 7 is 10, plus 6 is 16, plus 1 is 17. So we've got, those are matched. So if we look at each one of these atoms now, 3 and 3, that's a match. 7 and 7, that's a match. 6 and 6, that's a match. 1 and 1, that's a match. So then we would say this is balanced. Everything on the reactant side has the same totals on the product side. It's just rearranged. So we've got a balanced equation there. Okay, so another example, we've got AU2S3 plus 2H2 yields 2AU plus 3H2S. So we'll go through and list all the elements in the reactant side. So AU, S, and H. So gold, sulfur, and hydrogen. We'll do the same thing over here. AU, H2, so that's hydrogen, S is sulfur. So now we'll go through and find the atoms for each one of these. So starting on the left, we have AU, that's 2, S, that's 3, and then hydrogen here has a subscript of 2, and we multiply that by the coefficient of 2, which gives us 4. Now on this side, we have 2 golds, because 2 times the subscript of 1, then 3 times the subscript of 2 for hydrogen, and 3 times 1 for sulfur would be 3. So when we do 3 times 2, that's 6. So let's go ahead and total these up. So 3 elements here, so those match. 2 plus 3 is 5, plus 4 is 9. Over here, 2 plus 3 is 5, plus 6 is 11. So now we see 9 and 11, those do not match. So we can go through and check to see where it is that it doesn't match.
Gold, that matches. Sulfur, that matches, but hydrogen does not. So we have some coefficient up here that is incorrect. So that makes it unbalanced. So the total atoms on the left side do not match the atoms on the right side. So the reactants do not match the products. That goes against the law of conservation of mass. So we do not have a balanced equation there.